So the next instruction is that place the model on a bench or a table in front of you. So it's basically in front of me here. And then, let me just see where's the most stable. Okay, that's quite stable for this molecule. So it's there. So place the model in front of me, myself, and then imagine a mirror standing next to it. So you imagine there's a mirror here. What will you see? That's the question about. Yeah. So now what we're going to do, we're going to having a imaginary mirror here. I'm going to take this one away for a while. This is probably out of the whole thing. Okay. I'm going to construct a second model that is a mirror image to this one. So again, same approach. I'm going to speed up this camera, this video, so that you can see. I think you have done it because this is the same process. Gonna use this one again, 4 carbons. I'm gonna use all the single bonds again, and then 1 chlorine. Okay, and I will add the hydrogen later as the last step. And in here, what I need to construct is that a model that is a mirror image to this one. So again, I'll start with this carbon and the second one. Okay, let's see. Is it? Yep. So I hope this one looks like a mirror image. Let me just turn it around. Okay, so you have chlorine here. If you put, there's a divider there that more or less replicate this one and that one. This is the one, the same hydrogen, and that's at the back there. All right, and that's pointing that way. And then if I push it this way as well, it's very similar to each other. All right. So we have done the first 3 questions, and then the fourth one is first pick up the second model. This is the second model, and then assure yourself that it cannot be superimposed on the first one. So I'm going to take this model and I'm going to put it this way. Can it be on top of this? Can it be? You have to move it around. Ooh, can you move this around? So problem here is that I cannot move this, cannot change. Remember that I have to change this. I have to break this bond and change this from chlorine to hydrogen and hydrogen to chlorine to form this same one. Okay, so in this case, since I cannot superimpose it, it can be a mirror image. Okay, but I have problems trying to take this compound and put it in the same way, because then what happens in this compound is that even though this is pointing like this one on top, everything is the bottom here, but this hydrogen, so this chlorine will be on this side, and this is like a mirror image. There is what you call the carbon stereogenic center or asymmetric center. So this carbon, the one is attached to the chlorine, is the carbon that is a stereogenic carbon, a chiral carbon. Right, and then now you see number 6, remove 2 groups from this stereocenter, for instance methyl and chlorine, and switch their positions. So I'm going to remove this methyl group, and then I'm going to remove chlorine. So let's switch this chlorine here to the where it used to be a methyl group, and here I'm going to switch that methyl to where previously was occupied by chlorine. So now if I switch it around, I will get this model, because now chlorine is pointing this way. Same goes as well, and this can go this can go to the bottom, the same goes this way as well. Alright, so now these two models can be superimposed. So I can put it on top and they all appear very similar. In other words, can dissolve into one compound. They are the same compound, in other words, yeah. They are identical or the same compound. Now, so since this is a stereogenic center or symmetric carbon, I can then again re-swap. I can take this one. In real setting, this is going to be bond breaking, bond cleavage. Yeah, you can't do it in the real setting really unless it undergoes several reactions. So here I'm gonna just switch it over. It could have been chlorine, yes, but I'm gonna just switch it to here. And hydrogen is push it. Okay, harder. Okay, so now it's back to the earlier one, which is the enantiomer of this one, the first model.